Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to show you the solutions to the arithmetic reasoning subtest of the 5th practice test on my website. In case this is your first time finding my YouTube channel, I quickly want to mention that I recently created a website called mastertheasvab.com. There you can take 6 practice tests as well as estimate your AFQT score. All that said, let's go ahead and get started with today's video. Question 1 says body mass index, BMI, is equal to weight in kilograms divided by height in meters squared. A man who weighs 80 kilograms has a BMI of 20. How tall is he? So to do this problem, and we're going to need some space to do it, we have to convert what's given to us in a word problem to a mathematical formula. In this case, it's fairly easy to do. We're told that BMI is equal to weight in kilograms divided by height squared. And moreover, we're given the weight as well as the BMI. So those are two things we can plug into the formula right away. Bear with me, I'm using two screens now, so my pen's a little off. Just bear with me. So we're told BMI is equal to 20. We're told the man's weight is 80 kilograms, so we're going to plug that in where we see kg. And we're asked to find how tall he is, and of course we know, per the formula, that's going to be h squared. I'm actually going to take this and move it over here so it can have more room to work with. So we got 20 equals 80 over h squared. Now we're solving for h squared, of course. To do that, in other words, we want to get h by itself. So we got to address this 80 as well as this square at some point. The first thing I'm going to do is multiply both sides by 1 over 80. And in so doing, I'll be able to cross this out. So this will just become 1 over h squared. And this, let me go ahead and try to save some space. This will become 20 over 80, which I can quickly reduce by crossing out these zeros to 2 eighths. And I can reduce this further by dividing top and bottom by 2 to be 1/4. So we can see that we're off to a good start. We have 1/4 equals 1 over h squared. Now we have to get rid of this square, and to do that, I'm actually going to take the square root of both sides. And as it happens, you can break this up into two ways. I prefer to do it this way. Square root of 1 over the square root of 4 equals the square root of 1 over the square root of h squared. Square root of 1 is just 1, so we know this is just 1. Square root of 4 is just 2. The square root of 1, as I just said, is just 1. And the square root of h squared, this just crosses out the squared there, so this just becomes h. Now we cross multiply. H times 1 is h. 2 times 1 is 2. And we can see that we've now successfully solved for h, which is 2 meters. Okay? So for this one, you had to be pretty confident with your ability to convert the word problem to a formula. And then you had to figure out how to first get h by itself, and then get h squared to just h. Okay? Quite a few steps for that problem, none of which were too difficult. So with that one done, let's go ahead and move on. I wish I had more space to work on that problem, but I didn't. So that one's a little bunched up. I apologize. And you may have noticed that this 5th practice test is basically a combination of all the problems from the first 4 practice tests. So if you took this, after you took the first 4 practice tests, all these questions should seem pretty similar, excluding maybe 1 or 2 new ones. Number 2 says a dosage of medication is 13 cc's per 100 pounds. What is the dosage for a patient who weighs 275 pounds? So in this case, we have to set up a proportion to solve this one. We're told that there's 13 cc's per 100 pounds. How many cc's is there going to be for a patient who is 275 pounds? And of course, we're going to represent the unknown as x. Okay. So with that done, we can go ahead and cross multiply. We get 100 times x, which is 100x, equals 13 times 275. I'm going to work this off to the side. Again, 275 times 13. 5 times 3 is 15. We got to carry a 1. 3 times 7 is 21, plus 1 is 22. Carry the 2. 2 times 3 is 6, plus 2 is 8. Since we're starting this 1, we have to drop down a 0 before we begin. 1 times 5 is 5. 1 times 7 is 7. 1 times 2 is 2. Add. 5 plus 0 is 5. 2 plus 5 is 7. 8 plus 7 is 15. Carry the 1. 2 plus 1 is 3. Okay, so we have 100x equals 3,575. Now we're going to divide both sides by 100 to get x by itself. Okay, this crosses out. We're left with x equals 3,575 divided by 100. Fortunately enough, there's a trick to doing division whenever the denominator is 10, 100, 1,000, or so on. The trick is to count up how many zeros there are in the number and shift the decimal place either left or right accordingly. In this case, 100 has 2 zeros. Again, that decimal is right there. So we're going to shift this, since it's division, to the left twice. 1, 2. So without doing any work, I know 3,575 divided by 100 is just 3575, which is our answer right there. Okay? So that was that one, just setting up a proportion and using some mental math to solve the problem. And again, I have a new computer setup, so I'm still working on getting used to my new writing pad, so just bear with me. I'll eventually get my handwriting better. Number 3 says, during exercise, a person's heart rate should be between 60 and 90% of the difference between 220 and the person's age. According to this guideline, what should a 30-year-old person's maximum heart rate be during exercise? So, as was the case in the last problem, we have to convert, not the last problem, 2 problems ago, we have to convert this word problem to a mathematical formula, which we can then use to solve the problem. And we're told that the person's maximum heart rate should be between 220 minus the age. So let's go ahead and set this up. I'm going to represent heart rate as HR, and we're told that it should be between 60 and 90% of the difference between 220 and the person's age. So we got 0.6, which is the same as 60%, 220 minus 30, and on this side we got 0.9, and again 220 minus 30. Again, I just took exactly what was given in the word problem and converted it to a formula. In particular, I made it an inequality. In this case, we're looking for the absolute maximum heart rate. So we're just going to focus on this side of the equation. And as you can see, we just have some simple math to do to get this one. If you remember the order of operations, you always do, please excuse my dear Aunt Sally. That is, you do what's in parentheses first, exponents next, multiplication and division from left to right, and addition and subtraction from left to right. In this case, we do have parentheses, so we're going to start by working out what's in parentheses first. So again, we have HR less than or equal to 0.9, and we're going to be able to do this one in our head. 220 minus 30 is going to be 190. Okay, now we can just go ahead and, with that out of the way, move on to multiplication. And I'm going to do this off to the side because I don't want to make a mistake. Again, we have 190 times 0.9. In case you haven't worked with multiplication and decimals in a while, the trick is to get rid of the decimals by shifting it accordingly. In this case, I'm going to shift this decimal one time to make 0.9 just 9. And at the very end of the problem, I'm going to shift the decimal back into the left. So in reality, I'm working out 190 times 9, albeit with one decimal place to shift back in at the end. 0 times 9 is 0. Anything times 0 is 0. 9 times 9 is 81. Carry an 8. 9 times 1 is 9, plus 8 is 17. Again, shift that one decimal back into the left. And we can see that the absolute maximum heart rate for this 30-year-old should be 171 beats per minute, which is right there. Believe it or not, my handwriting is actually very clear on a board because those markers fit my hand well. The pen I have for my digital pen is very small, so I have to get used to it again. So just bear with me. All right, let's go ahead and move on to number 4. All right, number 4 says the temperature outside is 68 degrees Fahrenheit. What is the temperature in Celsius? Use Celsius equals 5/9 F minus 32. So they gave us the formula, which was nice. I'm just going to copy it over here. Celsius equals 5/9 68 minus 32. And again, I just plugged in 68 degrees for Fahrenheit, which was given. As was the case in the last problem, again, according to the order of operations, we work out what's in parentheses first, which would be 68 minus 32. Since I don't want to make a mistake, there's no shame in working that out to the side. Again, you're going to be given scrap paper on the ASVAB. I used a lot of it when I took it, so no shame in using your scrap paper, especially for the arithmetic reasoning section, which requires you to do a lot of tedious calculations. So 8 minus 2 is 6. 6 minus 3 is 3. We can see that this is going to be 5/9 times 36. And again, we got the parentheses done. Now all we have left is multiplication. I'm going to show you the easy way to do multiplication with fractions. You can regard this as 5/9 times 36/1. Again, all whole numbers can be written as fractions by placing them over 1. 5 can be written as a fraction by placing it over 1, so that could be 5/1. 100 can be written as a fraction by placing it over 1, so 100/1 would be the fraction. That's what I just did here with 36. Now, before I do this math, I'm actually going to reduce this. I know 9 goes into 9 one time, and I know 9 goes into 36 4 times. So I just reduced this before I went any further. And when you multiply fractions, you just multiply straight across. So in other words, you do 5 times 4 over 1 times 1. 5 times 4, of course, is 20 over 1. Anything over 1 is itself, so this is just 20, which we can see is the correct answer. Okay? Again, if I give you this fraction to multiply, you would just multiply straight across. So this would be 5 times 12 over 3 times 7. Okay? So that was that one. Let's go ahead and move on to the next one. All right, let's see if it gave me more space. It did. Good. Number 5 says Technician Smith makes $14 an hour. When she works more than 8 hours a day, she gets paid overtime pay of 1.5 times her regular hourly wage for the extra hours. How much did she earn for working 11 hours in one day? So again, we're told when she works 8 hours, she gets paid at a rate of $14 per hour. In this case, she works 8, 9, 10, 11, 3 overtime hours at a rate of 1.5 times her regular pay. So we need to first find out what 1.5 times of 14 is. So we're going to do, and again, you can write 1.5 as 1.5. That was sloppy. So I'm going to take 14 and multiply it by 1.5. Again, we're multiplying a whole number by a decimal. To make that math easy, what we're going to do is make this decimal whole number by shifting it to the right one time. And at the very end of this problem, we'll add that decimal back in. So in reality, I'm doing 14 times 15, albeit with one decimal to shift back in to the left at the end of the problem. 5 times 4 is 20. Carry the 2. 5 times 1 is 5, plus 2 is 7. We have to add a 0 since we're starting this number. 1 times 4 is 4. 1 times 1 is just 1. Let's add. 0 plus 0 is 0. 7 plus 4 is 11. Carry the 1. 1 plus 1 is 2. So, and shift our decimal back in one place. So we can see that her overtime rate is $21 per hour. So now I'm going to do 14 times 8 and 21 times 3. Then I'm going to add these two products together to find out how much she's going to earn in total in a day. 8 times 4 is 32. Carry the 3. 1 times 8 is 8. 8, 9, 10, 11. So 8 plus 3 is 11. 1 times 3 is 3. 2 times 3 is 6. Let's go ahead and add these two together. So we have 112 plus 63. 3 plus 2 is 5. 1 plus 6 is 7. And nothing plus 1 is just 1. So we can see that for her 11-hour workday, including with her overtime rate of pay, she would make $175. Okay, so that's that one. To make this practice test, I actually went through, as I mentioned earlier, all of the other practice tests and pulled out what I felt were the good problems. So this is a really good approximation of what the ASVAB is going to be like. Number 6 says your grades on 3 math exams are 80, 93, and 91. What grade do you need on your next math exam to have at least a 90 average on the 4 exams? So we need to set up a formula that's going to help us solve this accordingly. And more specifically, I'm going to use the formula for average. That's when you take all the data points, divide them by how many data points there are. In this case, we want the average to be 90, so I'm going to plug that in on this side of the equation. We know that we've already scored an 80, a 93, and a 91. But that said, we want to know what the score on the fourth exam must be to give us an average of 90. So again, it's the sum of all the data points over how many data points there are. There's 1, 2, 3, 4, including the unknown value, which I represented with x. So this is how we set up these problems. Again, my goal is to solve for x by itself. So the first thing I'm going to do is get rid of this 4 by multiplying both sides by 4. This simply crosses out. And 90 times 4 is actually really easy to do in your head. 9 times 4 is 36. Therefore, 90 times 4 is 360. And let me move that up a little bit so we can have some more space to work with. Again, 90 times 4 is 360. We're left with 80. That looks bad. Plus 93 plus 91 plus x. Now, the very next thing I'm going to do is combine all these numbers so I can move them over to the left as a whole. So let's go ahead and do that. This is where I usually make mistakes, doing the very basic arithmetic with 3 or more numbers. So let's take our time as we do that. We have 93, and let me get rid of that. We have 93, 91, and 80. Let's go ahead and add these up. 3 plus 1 is 4. Nothing to carry. 9 plus 9 is 18. 18 plus 8 is going to be 26. So we can see that this is 360 equals 264 plus x. As I said, we're trying to solve for x by itself. So I'm going to subtract 264 from both sides. This crosses out. I'm left with x equals 360 minus 264. Let's go ahead and work that out. 360 minus 264. 0 minus 4 we can't do. We have to borrow. This becomes 5. This becomes 10. 10 minus 4 is 6. 5 minus 6 I can't do. I have to borrow. This becomes 2. This becomes 15. 15 minus 6 is 9. And 2 minus 2 is 0. So we can see that x is going to be 96, which means that in order for you to obtain a 90 average on the 4 quiz, a 90 average in the class, you have to obtain a 96 on the 4th quiz grade. Okay? And again, you will see problems like this a lot, at least once on the ASVAB. So get used to doing problems like that. That said, let's go ahead and move on to the next problem. I don't know why it highlighted all that. Let me see if I can fix that. There we go. Alright, number 7 says, the half-life of a medication prescribed by a doctor is 6 hours. How many milligrams of this medication is left after 36 hours if the doctor prescribed 100 milligrams? So half-life basically means that every 6 hours the medication is going to be cut in half. So let's call this 0 hour. We're going to have 100 milligrams. Okay? After 6 hours, there's going to be 50. After 12 hours, there's going to be 25 milligrams. After 18 hours, there's going to be 12.5 1.5 milligrams. And again, you can see that as the hours go up by 6, which is the half-life, the amount of the medication is cut in half. Okay? The next amount is 24. Half of 12 and a half, that's going to be 6, and half of 5 is 2.5. Okay? Now we're going to go to 30. We're almost at our 36 mark. Half of 6 is 3. Half of 25 is 12 and a half. Okay? All right, so now we're at 36. We're going to take half of 3.125. Half of 3 is 1.5. Half of 3 is 1.5. Half of 12 and a half is 6.25. Okay, which is this one. I did this all in my head. If you needed to, at some point you could have done 12.5 divided by 2 and so on and so forth, but you should be able to do this division in your head. It's not that difficult to do. But that said, let me show you how to do division with decimals. In order to do division with decimals, you have to make sure that there's no decimal on this number outside the division bracket. As long as the decimal on the outside of the division bracket, as long as there's not a decimal in the number that's outside the division bracket, you can proceed. Basically, you take this decimal and shift it right up here in place, and you would go, how many times does 2 go into 1? It doesn't, it's too small. How many times does 2 go into 12? 6 times without going over. 6 times 2, of course, is 12. So there's no remainder. We drop down this 5. How many times does 2 go into 5 without going over? 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1. How many times does 2 go into 1? It doesn't. We have to add a 0. How many times does 2 go into 10? 5 times. 2 times 5 is 10. So there is no remainder. Okay? Again, either way, you can get the right answer as long as you understand that half-life means that after a certain amount of time, in this case it's 6 hours, the medication is basically cut in half. Okay? All right, number 8 says a submarine left Hawaii 2 hours before an aircraft carrier. The vessels traveled in opposite directions. The aircraft carrier traveled at 25 miles per hour for 9 hours. After this time, the vessels were 280 miles apart. Find the submarine's speed. So right away, we should recognize that we're dealing with elements of the distance formula. That is, distance equals rate times time. And in light of that, we have to be able to pick out what we have and what we don't have in order to solve this problem. In this case, they're trying to make it very confusing by giving you the fact that the two vessels are going in opposite directions. One left 2 hours before the other one, and so on and so forth. But as long as you can impose some order on that chaos, this problem is very easy. And to impose some order on it, here's what I'm going to do. We got a sub, which I'm going to represent as SUB. We have an aircraft carrier, okay? And for both of them, I know I'm going to need to use the distance formula to figure out this mess. Let's start with the aircraft carrier, since we're given quite a few of the elements of it. Specifically, we're told to travel 25 miles per hour, which is the rate, for 9 hours, which is the time. And using those two pieces of the distance formula, I can figure out how far it went. So in this case, again, we don't know how far it went, but we do know it traveled at 25 miles an hour for 9 hours, which tells us, again, 25 times 9. 5 times 9 is 45. Carry the 4. 9 times 2 is 18, 19, 20, 21, 22. Which tells us that the aircraft carrier traveled 225 miles out of the 280 miles they are apart. Okay? Which means that the sub had to travel 280 minus 225 miles. So let's do 280 minus 225. 0 minus 5 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 5 is 5. 7 minus 2 is 5. 2 minus 2 is 0. So this 55 miles is how far the sub traveled. So we know the distance that the sub traveled was 55 miles. We don't know the rate at which it traveled, so I'm going to leave that as R. But we do know, thankfully, the sub left 2 hours before the aircraft carrier. The aircraft carrier traveled for a total of 9 hours. 9 plus 2 hours is 11 hours. So that said, we know the sub traveled for 11 hours for a total distance of 55 miles. In this case, we can solve for R now by dividing both sides by 11. Let's cross this out. We're left with R equals 55 over 11, which is just 5. In other words, the sub traveled at a rate of speed of 5 miles per hour. Again, not a very difficult problem, but it was very messy in terms of the fact that we had to use information given from the aircraft carrier to finally set up a problem for the sub. And as you can see, in this case we found the distance, in this case we found the rate. Okay, so again, I have videos devoted exclusively to the distance formula on my YouTube channel. Check those out if you struggled with this. But overall, I thought this problem was pretty straightforward. All right, let's go ahead and move on to number 9. Grab my pen again. Oh, where'd it go? Let's see what I've done here. All right, let's grab the pen again. Right, there we go. All right, so number 9 says, in a manufacturing plant that produces new computers, a 0.15 probability exists that a computer will be defective. If 5 computers are manufactured, what is the probability that all of them will be defective? So in this case, we have to understand that this question is asking us to compute the probability of independent events. More specifically, we're being asked to calculate what are the odds that if 5 computers are produced, they'll all be defective. On my website, I uploaded a formula sheet that devotes, I think it's about 4 or 5 pages to probability, and it talks about how to find probability of independent events. In this case, it looks like this. Probability, we're being asked to find the probability of 5 independent events. That is, we're going to be asked to find the probability of A, B, C, D, and E. And to find the probability of independent events, you find the probability of A times the probability of B times the probability of C times the probability of D times the probability of E. In this case, that looks like this. 0.15 times, let me use a multiplication symbol there, time, bear with me here, times 0.15 times 0.15 times 0.15 times 0.15. So this says if 5 computers are manufactured, this is the probability that all of them will be defective. Okay? And again, to do this problem quickly and accurately, you have to have some number sense insofar as you have to be able to see that you're multiplying 0.15 times 0.15 times 0.15 times 0.15 times 0.15. Therefore, you know this can't be the answer, this can't be the answer, and this probably can't be the answer. And here's why. Let's do 0.15 times 0.15. Again, the key to multiplying decimals is to shift the decimal place to make those decimals whole numbers, and then shift the decimal place back in accordingly. So in this case, I have to move this decimal 2 times to make 0.1515, and in this case, I have to move the decimal place 2 times to make 0.1515. In total, I move the decimal place 4 times, so in reality, I'm working out 15 times 15, albeit with 4 decimal places to shift back in at the end. So let's go ahead and work this out. 5 times 5 is 25, carry the 2. 1 times 5 is 5, plus 2 is 7. Add a 0 since we're starting this row. 1 times 5 is 5, 1 times 1 is 1. Okay, let's add. 5 plus 0 is 5. 7 plus 5, 7, 8, 9, 10, 11, 12. Carry the 1. 1 plus 1 is 2. Again, we have to shift the decimal, which is right here, 4 times. 1, 2, 3, 4, which is going to be 0.0225. 0.0225 is already smaller than 0.042. And I only did this twice. If I multiplied 0.0025 by this, and then that result by this, and that result by this, it's going to be a very small number. More specifically, it's going to be this. In my video where this question doesn't have these easier answer choices, I actually worked this out. But as long as you can see that this number is going to be extremely small, and when you do 0.15 times 0.15, and it's already the smallest, the only number that's smaller than that's left as an answer choice is this one, just stop, pick the right answer choice, and move on. Okay? Sometimes the ASVAB set up so that you have to be able to see the answer choice without doing a tremendous amount of work. So hopefully you're able to understand that explanation. Probability is not my strong suit. I'm okay with it, but again, take a look at that formula sheet if you want more information about determining the probability of independent events. Alright, number 10 says, let me grab my pen. Number 10 says, an airplane traveled 1,824 miles in 3 hours. What is the average speed in miles per hour? Right away, we should recognize that there are all the elements of the distance formula in this problem. We have a distance, we have a rate, and we're being asked to find, we have a distance and we have a time, and we're being asked to find the rate. So basically, this is what I call a plug and chug problem. You write down the distance formula once you recognize that's what you're working with, and you plug things in accordingly. Again, the distance is 1,824. The time was 3 hours, and the rate's what we're trying to figure out. So we set this up. 1824 equals rate times 3. Again, we're trying to solve for r, so the next move I'm going to make is divide both sides by 3. This leaves me with just r equals 1824 divided by 3. This is where your long division comes into play. Again, we have 1824 divided by 3. And again, all fractions can be regarded as long division. Again, 1824 divided by 3. Now, you might be able to see this right away. 3 goes into 18 6 times. 3 goes into 24 8 times. So you should be able to do that mentally to see that 608 times 3 is going to be 1824 with no remainder. If you couldn't see that right away, and the more you practice long division, the easier it's going to be to see. The easier it will be to see instances in which you can do mental math to save yourself some time. Let's work it out the old-fashioned way. 3's too big to go into 1. 3 goes into 18 6 times. 3 times 6 is 18. Subtract 18 minus 18 is 0. Drop down this 2. Drop down this 4. 3 doesn't go into 2. So this is going to be 0. 3 goes into 24 8 times. 8 times 3 is 24 with no remainder. Okay? So that's that one. And I don't know if you can tell, but these tests actually take a lot out of me to do. You should feel the same way as you take them. They're not easy to do. And the arithmetic, as you can see, is very tedious. Number 11 says the product of two consecutive odd numbers is 399. What are the numbers? So there's two ways to go about doing this one. We can see that these are all odd consecutive numbers. So you can go ahead and do 17 times 19. See if that gives you 399. 19 times 21. See if that gives you 399. 21 times 23. See if that gets you 399. And 25 times 27. And see if that gets you 399. Whichever one gets you 399 is going to be the answer. We know it's this one. But the proper way to do this problem, and there's nothing wrong in many cases with just doing the brute arithmetic to solve these as quickly as possible. I would probably do it this way. But the algebraic way to solve this one is to set up an equation. Again, the product of two consecutive odd numbers. Let's say one odd number is x. That means the next odd number would be x plus 2. So for example, if x was 3, x plus 2 would be 5. And you can see that those are consecutive odd numbers. Equals 399. Let's go ahead and distribute this x here and here. This gets you x squared plus 2x equals 399. We're going to move 399 to the left. So it gets you x squared plus 2x minus 399 equals 0. From here you would factor this. This would give you x and x equals 0. Of course, we know the two factors are 19 and 21. But in this case, we're saying to ourselves, what two factors can we multiply by each other to get negative 399 that add to positive 2? That would be negative 19 and negative 21. Then you would solve for x. This would be x equals 19, x equals 21. Okay, so this is the algebraic way to solve this problem. In light of the fact of how easy this method is, I would stick with this method. Okay, so that's that problem. All right, number 12. Number 12 says a triangle with a perimeter of 60 inches has one side that's twice as long as the shortest side and a third side that's 8 inches longer than the shortest side. What is the length of the shortest side? So again, we have a triangle. Doesn't matter what it looks like. The perimeter of a triangle is just side plus side plus side. The perimeter of anything is just to add up all the sides. In this case, we're referencing the shortest side of the triangle for all these other sides. So I'm going to call the shortest side of this triangle x. We're told that one side is twice as long as the shortest side. If I let the shortest side be x, that means this one is 2x. And the third side, that's 8 inches longer than the shortest side. So if the shortest side's x, whoops, this side's going to be x plus 8. Okay? So again, the perimeter is adding up all the sides. We're told the perimeter is 60 inches, so I can plug that in for P. And again, we're just adding up all these sides, side plus side plus side. That's x plus 2x plus x plus 8. Let's combine our like terms. X plus 2x is 3x plus x is 4x plus 8. Again, we're trying to solve for x. So in other words, we want to get x by itself. Let's subtract 8 from both sides. This crosses out. We're left with 60 minus 8, which would be 52 equals 4x. Let's divide both sides by 4. This crosses out. Again, x equals 52 over 4. Let's go ahead and work that out right here. Again, fractions can be regarded as long division. 52 divided by 4. And let me give myself more room to work with this one. 52 divided by 4. 4 goes into 5 one time without going over. 4 times 1 is 4. Subtract 5 minus 4 is 1. Drop down this 2. 4 goes into 12. 3 times without going over. 4 times 3 is 12. So we can see there's no remainder. In other words, this says x equals 13 inches. X refers to the shortest side, so we know the shortest side is 13 inches. Right, number 13 says a pole 12 feet high has a shadow 4 feet long. A nearby pole is 24 feet high. How long is its shadow? So we got one pole here with a shadow. We got a much taller pole with a similar shadow. Basically, these are triangles, and these are similar shapes more specifically. So we're going to set up our proportion to solve this. Again, this one's 12 feet. This one's 24 feet. This one's 4. And this one is unknown. One thing I want to point out right away is when you double 12, you get 24. So we know that this scales by a factor of 2, which should hold true. So if this is a factor of 2, this is also going to be a factor of 2. 4 times 2 is 8. So I know that the shadow of the 24 foot tall pole would be 8. If you want it to set up a proportion, it would look like this. 12 over 24 equals 4 over x. 12x equals 24 times 4. 4 times 4 is 16. Carry the 1. 4 times 2 is 8 plus 1 is 9. 12x equals 96. Divide both sides by 12. Let's cross this out. X equals 96 over 12. If you know your times tables for 12. 96 divided by 12 is 8. Okay? So for this one, you could have recognized that this scales by a factor of 2, in which case the math's very easy to do. Otherwise, you could have set up a proportion like this, in which case you would have had to do a few more steps, including this one right here, where you may make a mistake to solve this one. So that's that one. Again, similar shapes. You usually use a proportion to solve. Alright, couple more to go and we're done. 14 says, what is the circumference of a circle that has a radius of 140 feet? Use 3.14 for pi. Again, you do have to know how to deal with circles to do well on the ASVAB. More specifically, you have to know the formulas to find the area as well as the circumference of a circle. Circumference equals 2 times pi times the radius, or circumference equals pi times the diameter. In this case, we're given a radius of 140, so we're actually going to use this formula. Let's go ahead and plug things in accordingly. Circumference equals 2. They tell us to use 3.14 for pi. Again, for the ASVAB, you're not allowed to use a calculator, so always use 3.14 for pi. And the radius is 140. The first thing I'm going to do prior to dealing with these decimals is do 140 times 2. I'll do that off to the side. 0 times 2 is 0. 4 times 2 is 8. 1 times 2 is 2. So circumference equals 280 times 3.14. Now we're going to do the messy math, as I like to call it. We got 280 times 3.14. Again, we're multiplying a whole number by a decimal. So I'm going to shift this decimal 2 times to make 3.14 314. And at the very end of the problem, I'm going to shift those decimal places back in. So again, in reality, I'm doing 280 times 314, albeit with 2 decimals to shift back into the left. And if you take a look, you could probably estimate this, approximate this answer choice pretty easily. 280 is about 300, 314 is about 300. So my answer that I'm going to be looking for is going to be about 900. 660 is not close to 900. 690 is not close to 900. 440 is not close to 900. So if I just wanted to guess, I would be guessing this one because it's the closest one to 900. But that said, let's go ahead and work this out. 0 times 4 is 0. 4 times 8 is 32. Carry the 3. 4 times 2 is 8. Plus 3 is 8, 9, 10, 11. We're starting this number, so we have to add a 0 before we begin. 1 times 0 is 0. 1 times 8 is 8. 1 times 2 is 2. Now we're starting this number, the third integer, so I have to add 2 zeros before I begin. 3 times 0 is 0. 3 times 8 is 24. Carry the 2. 3 times 2 is 6, plus 2 is 8. Let me go ahead and move this over here so I don't make a mistake. We have 1, 1, 2, 0, 2, 8, 0, 0, and 8, 4, 0, 0, 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 2 is 2. 8 plus 1 is 9. 2 plus 4 is 6, plus 1 is 7. 8 plus nothing is 8. shift our 2 decimals back in, 1, 2, we can see that the circumference is going to be 879.2, which is right there. Okay? So in order to do this one, you had to correctly recall the formula for circumference, and then you had to be able to do the arithmetic, notably multiplication of a 3-digit integer by a 3-digit integer with decimals, which can get very sloppy, to solve this one. Alright, grab my pen real quick. Number 15 says a field measures 40 yards by 30 yards. If a person wanted to walk diagonally from one corner of the field to the other corner, how far would she walk? So again, since the field is 40 by 30, we know it's a rectangle. And again, 40 is longer than 30, so we know the length is 40 and the width is 30. We're asked to figure out how long she walked if she made a diagonal walk across the park. And we should recognize right away that when you cut a rectangle in half with a diagonal, you actually create 2 right triangles. And this diagonal is actually the hypotenuse. Let me go ahead and pull this off to the side like this. So this is one slice of the rectangle. Again, this is 30 and this is 40. The hypotenuse is always identifiable as the part of the triangle that's always directly across from the right angle. So in this case, to find the length of the diagonal, which I'm going to call C, we're actually going to make use of the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b refer to the legs of a right triangle and c refers to the hypotenuse of the right triangle. We do know the legs of this one, 30 and 40, so we can plug those in. These are fairly easy to do. 30 squared is 900, 40 squared is 1600 equals c squared. 1600 plus 900 is 2500 equals c squared. Again, we're trying to solve for c to find the length of the diagonal, which is the hypotenuse. So we're going to take the square root of this. Square root of 25 is 5. The square root of 2500 is going to be 50. So we know c is equal to 50. Therefore, in order to walk the diagonal of this rectangle, which is the same as the hypotenuse of a right triangle, she would have to walk 50 yards. All right, final question. I hope I gave myself an easy one to do. I'm starting to run out of steam here. It's not too bad. A dress that cost $175 is on sale with the discount of 25%. What is the sale price of the dress? So before I begin, I'm going to kind of jot this one down so I can keep track of things. The sale price is going to be equivalent to the original price minus the discount. So again, sale price is equal to the original price minus the discount. So that looks like this. We know the sale price. The sale price is what we want to figure out. So I'm going to let that stay as SP. I know the original price of the dress is $175, and I know it has a discount of 25%. So I have to figure out what 25% of 175 is. So to figure that out, I'm going to do 175 times 0.25. Again, we're doing a whole number by a decimal. We're multiplying a whole number by a decimal. We're going to shift this decimal place 2 times to make 0.25 just 25. So in reality, I'm doing 175 times 25, albeit with 2 decimals to shift back into the left at the end. 5 times 5 is 25, carry the 2. 7 times 5 is 35, 36, 37, carry the 3. 5 times 1 is 5, plus 3 is 8. Add a 0 since we're starting this number. 5 times 2 is 10, carry the 1. 7 times 2 is 14, plus 1 is 15, carry the 1. 2 times 1 is 2, plus 1 is 3. 5 plus 0 is 5. 7 plus 0 is 7. 8 plus 5, 8, 9, 10, 11, 12, 13. Yes, I did use my fingers to do that. Carry the 1. 3 plus 1 is 4. We're not done yet. We have to shift our 2 decimals back in. 1, 2. So I know the discount is going to be 43.75. So in other words, the sale price is the original price of 175 minus the discount of 25%, which is the equivalent of 43.75. So now I got to do 175 minus 43.75. Again, I'm subtracting decimals. The key to subtracting decimals is to line up your decimals. So in this case, we know we're just going to drop our decimal in place right there. And as you can see, we have 0 minus 5, which we can't do, and 0 minus 7, which we can't do. So I have to borrow from here to make this 4. This becomes 10. To borrow one more time, this becomes 9. This becomes 10. And now I can solve this one. 10 minus 5 is 5. 9 minus 7 is 2. 4 minus 5 I can't do. I have to borrow. This becomes 6. This becomes 14. 14 minus 5 is 9. Uh-oh. I've made a mistake somewhere. Where have I made a mistake? This should be a 1. That's a 3, not a 5. Sorry about that. I do not have to borrow. Let's go ahead and start over since I made that mistake. My fault. Again, this test is taxing, so even someone who's pretty good at math will make simple mistakes. 175 minus 43.75. Again, I'm going to borrow from here. This is going to become 4. This will become 10. I have to borrow one more time. This becomes 9. This becomes 10. Drop your decimal in line. 10 minus 5 is 5. 9 minus 7 is 2. 4 minus 3 is just 1. 7 minus 4 is 3. 1 minus nothing is 1. So we can see that this sale price is going to be $131.25, which is right there. Okay? So that's it for this video. I hope you found it helpful. Again, as you can tell, these questions are taxing even for me. The more you go through these practice tests, the more you're going to build up your stamina for test day. So again, if you're suffering a little bit now, that's a good thing, because on test day, you're going to suffer that much less. As always, I appreciate any feedback you leave in the comments section of my videos. In addition, if you found my content helpful, feel free to share it with friends. Give this video a thumbs up. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.